Now we're going to learn how to find the derivative in the form of a function. Or in other words, we're going to find the equation for a derivative. So the first step is to draw a picture that's sort of similar to the one that I drew for the derivative at a point. So in this case, we're going to be trying to find the derivative at a point x. So our f of x value is over here, and we're going to represent our change in x as delta x. So this point over here represents x plus delta x. And then over here we have f of x plus delta x. And this is representing our change in y, so delta y. Now we have our difference quotient that looks more like change in y over change in x. So similar to what we did for the derivative at a point, we can represent f prime, or the derivative of the function f of x. We can write this as the limit as the change in delta x, or just delta x, approaches 0, and our difference quotient, or I guess in this case it would just be our quotient, would be delta y over delta x. We can also write this as the limit as delta x approaches 0, and our change in y is actually equal to f of x plus delta x minus f of x over x plus delta x minus x. And if we rewrite that one, or just, I guess, simplify it, we get f of x plus delta x minus f of x over delta x. So as you can see, this basically represents the instantaneous rate of change because delta x is approaching 0, so it's going to be an instant rather than an average rate of change. So one more way to write this is using h. Some people like to write a single letter h instead of writing delta x, and this h represents or stands for horizontal, and it's simply to make the algebra easier to write. So instead of delta x, we would have the limit as h approaches 0 and f of x plus h minus f of x all over h. So here is our first way to write the derivative as a function. This is our second way, and this is our third way.